This is Unit 12, Statistics. This is Part 3, Dispersions. This is video number 2 for that, so it's video 4 overall. This section we will focus on using the graphing calculator to answer questions about standard deviation, variance, mean, median, and mode. And if we need to, we will break this into 2 videos. Let's look at question 1 on this sheet that we left off on last time. And it was the table below shows the first quarter averages for Mr. Harper's statistics class. So it lists all the averages and the frequency of those averages. And the question is asking us about population variance. Now, if you remember from the last video, I stated that population standard deviation was given by sigma x, and that variance is the square of your sigma. So just to shorten the amount of time that we spend here on the video, I preloaded this information, into a list called averages, and this information to a list called frequency in your calculator. So if you come here in this document, I have the averages listed and the frequencies listed, and you can see that there are 11 different categories of averages with their frequencies. If you've forgotten how to get a page like this, if you go to a new document or a new page, this is under lists and spreadsheets. This is where you would enter your lists. It looks like a spreadsheet. You give it a title, you always skip the equals line, and then you enter your data. In this page 3, I've set up a calculator page because we would like to do some calculations to find out some more information about our statistics. So if you go to Menu, and statistics is our choice. We're going to do some calculations, like I just said. And we're going to do one variable statistics because we don't really care about the frequency. That's not a second variable. That's just more information about our first variable, which is averages. And we only have one list. All of our data is in the first list. Our X list is called averages. And then look at that. They ask us, do you have a frequency list? If you don't have a frequency list, then you choose 1. But if you do happen to have a frequency list, ours is called frequency, you can choose it from the drop-down menu here, and then you click OK. What you get back, and I scrolled up so you could see it, is it gives you a title. This is one variable statistics. If this is not what you meant, you have to go back in and redo it. X bar is our mean, which is 88.0571. Sigma x is what you get when you add up all of our pieces of data, which is 3,082. If I was going to square each piece of data and then add it up, I would get 273,748. Sx is our sample standard deviation, and this is 8.32411. Sigma x is our population standard deviation of 8.20433. which we need this to get our answer to our question. We'll come back to it in a minute. Just going to refresh your memory on all of this. N is your sample size, which is 35. And in the last video, I showed you how to calculate by hand the 5-number summary, but it's listed here. Your min, your quartile 1, your median, your quartile 3, and your max. So anytime you need to get that information, if you don't want to do it by hand, you can plug it into a list on your calculator and it will find it for you. So going back here, S stands for sample. O, kind of like the O1 is for population. We need this 8.2. So go back to our document. We need to take 8.2 and we need to square it. So if we square 8.2, which I'm just going to show you a quick way to do it. The variable that I used last was our population standard deviation, and I just choose that from variable and square it. It will give me 67.311, or you could have just done the 8.2 squared, and you get 67.2. Well, let's look at our choices. We have a 67.3. That would be our best choice. Okay, we did this question on the last video, and this question up here as well. So let's move on to the next page. This is more information of just quick and easy things like how do you find the range? Remember, it's the highest number, subtract the lowest number. Moving to dispersion 3, there is no dispersion 2 in your packet. There is no dispersion 2 that exists at all, in fact. If we look at this, again, we're calculating measures of dispersion for both samples and population. So if we look at these questions, there's a couple of general questions about these that you can answer yourself. When we come back to school, I will give you the answers to all these packets. I'll just photocopy the answer keys and you can correct yourself on Tuesday night. But let's take a look at number 3. Jean's scores on 5 math tests were 98, 97, 99, 98, and 96. Her scores on 5 English tests were 78, 84, 85, 72, and 79. Without using a graphing calculator, because most of you don't have one right now, which statement is true about the standard deviations for the scores? It doesn't say without using a graphing calculator, but I will let you know that you could do this without it. Remember that standard deviation is a measure of spread, and that the higher the standard deviation is, the further spread out your information is. So if we're looking at Jean's math scores, she has between a 96 and a 99. Those are very close together. That means her standard deviation here is going to be very, very small because the spread is small. If you look at her English scores, we go from a 72 to a 95. Her standard deviation is going to be larger than it was for her math scores because her data is more spread out. So what is true? 1, the standard deviation for English is greater than that of math. That's probably true. Let's just keep looking though. The standard deviation for math is greater than that of English. No, that one's very small. They're equal? No. The English scores are more spread out than the math scores, and more information is needed to determine. No, we just talked about the fact that all we need to know is how far their range is, how big their spread is. So the correct answer here is number 1. Now, look at this question. It says, find the standard deviation to the nearest tenth. It says the scores on a math test are. Now, you have to decide, is this a sample or is this the population? Are there any other scores to a math test that we're aware of? Since there does not seem to be any other scores, we're going to assume that it wants us to find this to be the entire set of data, the entire population. Otherwise, it would use the word sample. Okay, so we're going to assume that we are looking for the population standard deviation. I entered all of this information already into my calculator into a separate sheet. So right here, I called it math test scores. And there are 16 pieces of data. Okay, so now we're going to need another calculator page, which I have set up already. And we are going to again do statistics, a stat calculation. And if you recall, it's under one variable statistics. I have one list and only one list this time. So my X list is going to be the math test. My frequency list, this time I only want you to count everything once. There is no second frequency line. So we count everything once, click OK, and we look at our results. And we look at the mean, and we look at the two standard deviations. We have 16.7 and 16.2365. Going back to the question, it says define it to the nearest tenth. So we're going to say population standard deviation. Just be clear which one you're writing down because you don't want to get it wrong for that. So 16.2365 is what I would want to write out. I'm going to put this in typing. 16.2365. Did I get that right? Yep. And rounded to the nearest tenth is 16.2. Now again, if I used sample, I would have gotten this half wrong because it did not specify to use it for a sample. It does not say a sample. Okay? So it says find the standard deviation for the following set. When you see that, you assume that you are looking at the entire set of information. It does not say that this is a sample. So you're going to use the population. Going to this, in here where they're telling you to use the population standard deviation to the nearest hundredth. Here, 10 teachers at the school. Here, they're just telling you to do the standard deviation. Here, you know that this is 10 of a total number of presidents. Here you know that there are more presidents than 10, so this is a sample standard deviation that you would be using. Okay, you know that there are more presidents than you have in front of you. Okay, snowstorms of note, here they are over a 4-year period. The mean population standard deviation. So again, this can all be found using the 1-var statistics. If you are interested in calculating it by hand, there are, you can Google standard deviation formula by hand, and we'll show you how to do the hand calculations. If you are somebody who wants to do it all by hand, I will warn you, however, that that will take quite a bit longer than just typing into the calculator. We're going to end this video before we get to worksheet dispersion 4, and the last video for dispersion will be for worksheets 4 and 5.